Hello everyone, myself Madhibhushana from CSE department. Today let's learn about fractional knapsack of greedy method. The fractional knapsack problem is a classic optimization problem in computer science and operation research. It is a greedy algorithm problem and a variant of the standard knapsack problem. Greedy method is a problem solving technique that makes the locally optimal choice at each step with the hope of finding the best solution for a given problem. The key principle of greedy method is that to make the best choice in each current step, considering only the ultimate optimal solution, and do not consider previous choices, and also aim for simplicity and efficiency. About fractional knapsack now, there are steps in which we need to take measures of to solve a given problem. The steps include like for a given set of objects and profits and weights, we need to first compute profit and weight of the given objects, and then we need to arrange the profit by weight in descending order. And after arranging them in descending order, we need to find the solution vector, which we will do it in the following example, and also find out the percentage of the object selected for the maximum optimal solution. And for the example, let's take for 5 objects and which has maximum capacity of 100 kgs. We have taken 5 objects: object 1, object 2, object 3, object 4 and object 5, which profits 20 profit and weight is 10, and object 2 has profit as 30 and weight as 20. Object 3 has profit as 66 and weight as 30. Object 4 has profit 40 and weight 40, and object 5 has profit 60 and weight 50. And we have the profits and weights of the given particular objects. And first let's do step 1. For object 1, we need to do profit 1 by weight 1, which will be 20 by 10, and it is 2. And for object 2, profit by weight will be 30 by 20, which is given as 1.5. And for object 3, 66 by 30, which is 2.2. And for object 4, 40 by 40, which is 1. And for object 5, it will be 60 by 50, 1.2. And next, step 2, arrange them in decreasing or descending order. We have all the profit by weight values for particular objects over here. We need to list them out in descending order and write the corresponding objects over here, which we have written like 2.2 first, 2 is second, and 1.5 is third, 1.2 is fourth, 1 is last one, and object 3, object 1, and we have written the particular objects of the profit by weight. And for the last step, we need to take the columns as objects, weights, profits, and the ratio of the object or the weight taken, and the final profit taken by each object with combining with the ratio, and the remaining capacity of bag upon filling up each objects. First, let's take the highest profit by weight value, which is object 3. We have taken object 3 and we have included all of the weight because the maximum capacity is 100 and we can easily fill out 30. We have taken the weight as 30, and the corresponding weight profit for 30 is 66. We have written the profit as 66. We are taking the complete value of the object 3, so we have taken the ratio as 1, and the total profit would be a ratio into profit, which will be 1 into 66 equals to 66, and the remaining capacity, which will be the maximum capacity 100 minus 30, which will be 100 minus 30 is equals to 70. And now let's take the second one, object 1, which will be the second one in the descending order of profit by weights. We have taken the complete weight of it because we can fit 70 minus 10 easily. Weight would be 10, and the profit for object 1 would be 20. We have taken 20, and the ratio of the object is we have taken the complete object, so it is 1, and the final profit would be 1 into like ratio into profit, which is 20, and the remaining capacity would be maximum remaining weight after adding the object and minus the weight of the current ordered object, which will be 60. And next, the third one would be 1.5, which is object 2. We have taken object 2, which weights 20 value. We have taken 20, and the corresponding profit for that is 30. We have taken 30, and we are taking the complete ratio because we can still add 60 by minus 20. We can still add it. The remaining capacity is greater than the weight, so we can still add it out. and the profit would be 1 into 30, which is 30. We are taking the complete ratio, and 60 minus 20, 60 minus the weight of this, which would be 40. We have remaining capacity as 40 now in the bag after adding the three objects which are given here. And the last on the fourth one, the fourth value in the profit by weight ratio would be 1.2. This is object 5. The object 5's weight is 50. We have taken 50, and the corresponding profit of that is 60. But here we can't include the overall object 5, because the remaining capacity is 40 and the value, the weight of the object 5 is 50. So we need to take the ratio of the particular object. So we are taking it 0.8, because 50 into 0.8 is 40, and we can balance it out with the remaining capacity and make it to 0. So in this way we can take the fractional quantity of the object 5 and fill into the knapsack. The ratio as said, which will be 0.8 to make it 40, and the final profit, which is like 0, the ratio into the profit, which will be 48. This is the profit taken by object 5, because we are taking the ratio or a fractional value of object 5, and the remaining capacity would be 40 minus 40. Here don't confuse 40 with 50, because we are taking the ratio of it, so we need to take 15 to 0.8, which will be 40. 40 minus 40 is 0. The knapsack bag is all full now after adding 4 objects. So let's take down the solution vector for it, for object 1, 2, 3, 4, 5 correspondingly. For object 1 we have taken the ratio as 1 over here. Let's take 1. For object 2 the ratio is 1, 1. Object 3 the ratio is 1, 1. And we have not included object 4, because the remaining capacity is already full before we could take the 1, the last value in the descending order of profit by weights. So we have taken it as object 4 as 0, or we can say we can skip it. And object 5 would be 0.8, because we have taken the fractional value of the object. We are doing this problem to find the most optimal solution or the maximum profit of a given set of objects, and we get that by adding all the final profits of the taken values, which would be 66 plus 20 plus 30 plus 48. We are taking 48 for the profit of object 5, because 16 to 0.8, which will be 48. We are taking 0.8 or 80% of the given object 5, so it is 48. And upon adding all these values, we get the maximum profit as 164, which we can say is the most optimal solution, or the maximum profit we got of the given particular fractional knapsack problem for these particular profits and weights. And now we can say that we have successfully understood fractional knapsack, and the conclusion of it would be that the fractional knapsack problem demonstrates how a greedy algorithm can be effectively used to solve an optimization problem such as a knapsack problem. And in this, the speciality of the fractional knapsack is that we can take a fractional part of an object, unlike 0 1 knapsack where we have to take a whole of an item, such as we have taken 0.8 ratio or 0.8% of the object 5. But in 0 1 knapsack we are not able to do that, and we'll have to miss out on the remaining 40% capacity of the take the given objects. So this is more efficient and optimal for a given knapsack problem. We can use this fractional knapsack in applications such as resource allocations, cargo loading, and financial investments. The time efficiency of this would be n log n. Thank you everyone.